Welcome to ROS command line tutorial. Now this tutorial assumes that you have the VirtualBox up or you've installed it on Windows. Now first things first, if you're going to use the Windows or the command line for ROS2, you have to make sure ROS2 is sourced. So on Linux it would look something like this: source opt ROS iron, and then setup.bash. On Windows there's a setup.script or a bat I believe you can run. Now you don't actually have to do this if you've on the Linux side, and I believe there's a way to do this on Windows as well, but in Linux I've already written a configuration for the bash rc. Now the bash rc is a file that gets run whenever you start a new terminal. And you'll see down here that it will automatically source that along with source two other packages that I have installed on this virtual machine. You can ignore this. In fact, we're not going to be using fast RTPS for various reasons. So you ignore anything that has a hash mark in front of it. And just for the sake of this class, we're going to use the ROS domain ID of 44. This basically says, what robotic application are we using? So that's why if you're using the Linux virtual machine, you don't have to source this every time. It will do it automatically for you. In fact, when we get to creating a package, we're going to add your package to this so you don't have to keep adding it. All right. Now, everything on ROS2 is run through the command ROS2. This is a little bit different for those of you who used ROS1. Remember, there were several different commands, but ROS2 basically gives you this. And all of these are various different elements or subcomponents of ROS2 that you can run. One that's interesting is ROS2 package. You see there's a couple different packages. I can look up a package and I can look up the executables within a package. So ROS2 package list. You'll see that there's a couple here. So let's look at Unity Sim. This is one that I wrote, which we'll be using later. ROS2 package executable, and then Unity Sim. And then these are the three different executables that I have in this particular package. This is used to generate an odometry message for your simulation robot, and this was used to spawn the robot in the Unity simulator. Again, we'll come back to that later. So ROS2 package will give you everything that's installed. Some of this we'll use, some of this we won't. The next one is probably the most useful and necessary is run. ROS2 run. This is where the party gets started. ROS2 run is the following syntax: package and then executable. So I want you to remember this. ROS2 run, package, then executable. It'd be a great quiz or test question. So what we're going to do is there's a package called Sim, and if I can hit tab and it will list everything that Sim has for executable. So in this case we're going to use make a Sim node. This is the server. This is the node that represents the object in ROS2 that's going to have its own set of topics it's publishing and subscribing to. So we're on Sim node. I hit enter, and now I have a nice little Sim, and I'm running a ROS2 node. So if you're in Linux, you can do Control-Shift-T, and that will open up a new terminal. ROS, if you're Windows, make sure when you open up a new command line that you have it sourced, otherwise you won't be able to run this. The next interesting thing to think about here is topics. Now, as I mentioned in class, or will mention in class, topics are how these different nodes communicate. You can think of ROS2, or the publish subscribe architecture, as a giant graph. Each node on the graph is a program that's either listening or publishing information on a topic. So ROS2 topic list. Now, if you was using ROS1, we'd be using ROS topic. So if you see me type ROS topic, that's where I'm getting the habit from. So these are all the topics that are currently known in this system, this ROS2 system on this VirtualBox. If you have set the ROS domain ID correctly and you're on a LAN network, you should be able to see packages and messages from other computers. You will probably not be able to see it through the school's network for various reasons, but in class when we have our wireless router, you should be able to see it. So these two are default for ROS. They just come with when you're running a ROS listener or ROS participant, I guess you call it. That's what this computer would be. But these three are actually from the Turtle simulator. So we can kind of guess that turtle1/command velocity is how we would actually send a message to this turtle. Now, interestingly enough, this doesn't help us that much, because if I wanted to write this programmatically or use this, I have to figure out how is this message composed. But I don't even know what type of message command velocity is. Once again, this is a little bit different than ROS1. ROS1 would use ROS message info, where you're going to use ROS2 interface. Actually, no, not yet. We're going to use topic info, and then our turtle one, and you can use tab complete command velocity. So ROS2 topic info, this is information about this particular topic. This parameter has to be a published topic or a subscribed topic. It cannot be just a topic that an interface, as I'll show you in a moment. So it shows that there's 0 nodes publishing, which makes sense, and there's 1 node subscribing, which is our turtle sim. And I see that our type is geometry messages message twist. Well, great. Now this gives us a rough idea of where we could go in our code, but we want to see what that doesn't really tell us how this object is composed. Now this is something that you will use a lot throughout the semester when you need to figure out how a message is, or interface as they call it, as you'll see in a moment in ROS2, how it is composed programmatically. So it's ROS2 interface info. Now this will give you, instead of a topic, we're going to give a specific message type, or as ROS2 calls it, an interface. You do need the entire path. This is also a new in ROS2. Apparently not. Hold on. Let me see. Maybe I got the wrong one. Show. Sorry, excuse me. I apologize. It's show. Up arrow will allow you to repeat the previous line. You keep hitting up, you can go up to history. So ROS2 interface show, excuse me, geometry message twist. And here is our object. Now, how you read this is any data that's all the way to the left will be a direct member variable of this type of object. What does that mean? Here, let me show you. So let's say I have a function. I'm going to use Python at the moment. And it was actually being a class, but if I do data dot, the two variables, member variables available to me will be linear or angular. So I could do linear, which as you see it's a vector 3 type. I can do dot. Once I do dot, I can now access any variables inside here, x, y, or z. Likewise, I could also say data dot angular and then access x, y, z inside the angular if I need to. So this is an example of how you would learn how to program a message by using the ROS interface show. All right. We will come back to this later, but I wanted to show you just how you would reference that. Now, next step here. Well, this is interesting, but not very exciting. So another thing we can do is ROS2 turtle sim again. I could spell turtle sim, it would help. Turtle sim. Oh, sorry. ROS2 run. Turtle sim. Turtle sim turtle underscore teleop key. So ROS2 run turtle sim turtle teleop key. This will give us a command or a program that's built in that will allow us to control our turtle. So I can use the keys it mentions, and as you can see, my turtle is moving the direction I'm facing. Not very exciting, but we can make the turtle spin. I can also use the arrow keys and kind of control the turtle as I feel fit. And as you see, as we move the turtle, it's interesting. It makes it interesting. Now, if I can hit F, I can stop it. Now, what does this mean? This means that this program is sending messages of type twist to this program. So can we see that? And the answer is yes, we can. So ROS2 topic echo slash turtle. Now we give the topic name we want to echo. So in this case, turtle1 command velocity. And at the moment, nothing's happening. But now if I move around a little bit, maybe. You'll see that it in fact received a bunch of different messages. And it's only receiving a message when I've changed. So here I started rotating, it changed my angular on Z. I started moving forward, it changed my angular on X, or linear on X. I rotated again, angular on Z. I started moving forward again, then started rotating and moving forward. And then the last one should have been stop, I guess. Interesting, it didn't catch the stop, but anyway, maybe it was a service, but it stopped. The turtle stopped. So this is showing you the messages that are being sent on this topic, giving you the live data, and from this program that's being received on this program. All right, another thing we can do is ROS service. And here we can see all the different types of services. So let's just see what we have for ROS2 service info. Let's see, what options does service give us? Find, list, type. We'll do type. ROS2 service type, and we'll say spawn it says, okay, this is a turtle sim serve spawn type. Now, we're probably not going to use services a lot, but I was just going to show you this to you because we are going to use something similar to this for the Unity simulator. So I can do ROS2 service call spawn, and then I need to give the type, which I should be able to autocomplete, turtle sim. And now I need the message itself. So this is giving you kind of the JSON of it. Now this part is a little wonky. So we're going to say open curly bracket x colon 0 0 comma y colon 0 0 comma theta 0 0 and name, which means single quotes, Bob. Now this part is just awkward and I may not have got the syntax right, we'll see, but this is basically JSON and these are the individual elements x, y, and theta, and then the name, I believe it's separated by commas, so we'll find out if I got it right. It did, and my turtle spawned down here, so that was actually lucky on my part. So this is how you can call a service directly from command line. I can actually call a service from, or a topic from command line as well. ROS2 topic pub, say command turtle 1 / command velocity. Then it should give me the, so it gives me the message geometry, quit, so geometry. And now here I could fill in the JSON for it. I'm not going to, but I could actually publish a topic and move the turtle through command line this way. This is useful for very simple topics or interfaces. It is not as useful for something like Twist. One other note before we close for this session, if I do ROS2 topic list once again, I will see that I now have Bob, command velocity, Bob color sensor, Bob pose, the same 3 topics that the basic turtle gave you because I spawned a new turtle. This is similar to how the Unity simulator is going to work. When you specify your name, the Unity simulator is going to give you some different topics that from your name and these different topics that you can use. So that concludes an overview of ROS command line tools. It's very important that you familiarize yourself with each one of these, especially ROS run and ROS topic. ROS2 interface we'll use more when we get into the programming side of it. But again, make sure you're very familiar with how to use ROS. If you're using Windows, make sure you're very familiar with any particular, opening multiple terminals and making sure that ROS2 is sourced. Thank you, and I will talk to you later.